flea crawls along a parabola given by the equation y is equal to x squared in such a way that its x coordinate at time t is given by 2t plus 1. This is really a parametric curve, if you want to think about it. We're graphing out some type of function that follows another function. So we have a sun shining from the east, which is the positive x-axis, so that a shadow is cast on a wall that's built on the positive y-axis. What's the velocity of the shadow at t equals 3? So let me go ahead and draw you out a picture of what's going on here. So let's delete that. I really only need this side over here, so I'm not going to waste my space. So here's the curve x squared. That's right here what we're talking about. And so there's this little flea on there, okay, and he's going to start out here. And the flea's position, its x-coordinate as a function of time is equal to 2t plus 1. Let me explain what that means. At t equals 0, its x value is 2 times 0 plus 1. I suppose I got to change that now, huh? He's not at the origin. He, at time 0, has an x-coordinate of 1. So if his x-coordinate is 1, let me go ahead and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, close enough. So at t equals 0, when t is equal to 0, the flea has an x-coordinate of 1, but he's crawling along this line. So the flea is right here. Okay, that's at t equals 0. When t equals 1, at 1 second, his x-coordinate is 3. So he's already over here at x equals 3. And so the flea has moved along the line like this, and there he is. Okay? He initially started out, his shadow was at a height of 1. Then, now his shadow is at a height of 3 squared, which is 9. Okay, let's do another one. So at 2 seconds, I suppose I should put these arrows in. X at 2 is equal to 2 times 2 plus 1. So he is 5 units over. So 1, 2, 3, 4, 5. This is at 2 seconds. And now the flea is here. And his height value, I'm not drawing those in the best, is 25, right? And so he's been moving along the curve. And let's do one more. At time 3, his x-coordinate is 7. And so he is up here. His height value, or his shadow value, is at 49. Okay. Now the question is, what is the velocity at t equals 3? So we have a function, our purple function here, this guy, f of x is equal to x squared. What we would like is f as a function of t. We'd like to know how his height is changing as a function of t. So what we're going to do is we're going to say, well, x is equal to 2t plus 1. So f as a function now of t, okay, is equal to 4t squared plus 4t plus 1. Now watch. If you ask, so what is the height? Where is his shadow at time equals 3? We get 4 times 3 squared plus 4 times 3 plus 1, which is 4 times 9, 36, plus 12, plus 1, that's 49. There it is. So this new function takes t is an input and gives us the height over here as an output. So when t equals 3, the change in height of the shadow with respect to time, so the change in the y value with respect to the change in time, okay, is going to be equal to the derivative of this thing right here, which we know is going to be 2 times the a value times the t value, the variable, plus the b, which is equal to 8t plus 4. So f prime at 3 seconds is 8 times 3 plus 4, which is 24 plus 4, or 28. And this doesn't give me it in inches or anything like that. So let's assume that it's in inches. So we'll say inches per, and we'll assume our time is in seconds. Okay, so inches per second. But it tells us here that the change in the shadow is changing at 28 units on this axis per second at 3 seconds.